Hi everyone.
Okay, so I think we can get started, and if anyone else joins, they can join. But today we're going to be doing a quick review of like the unit circle and the trig identities. So I think last class Derek and Minnie covered the unit circle. So we're just going to do a review of that and then do some practice questions, and then the solutions will explain like how to approach the practice questions. So we're going to start with that, and then if we have time at the end, we're going to do some AMC problems just so you don't forget how to do them. So, yeah. So, Annie, can I get started? Is that good?
Yeah, it's all good.
Okay. So first we're going to be starting with the unit circle. So just a quick review, the unit circle is called the unit circle because it has a radius of 1. So when we draw any triangle using the origin, that's not supposed to say endpoint, origin and then any point on the circle, the hypotenuse is always 1. So if we draw a triangle here, it would have a hypotenuse of 1 and so on. And make sure you know both radians and angle measures. Obviously, this takes some time to get used to, like learning what an angle is in radians. So just a quick reminder, when going from radians to angles, you multiply by 180 over pi, and when going from angles to radians, you multiply by pi over 180. And then the coordinates of each point give you the value of the sine and cosine of that angle. So again, the x-coordinate is the cosine, and then the y-coordinate is the sine. And then to find the tangent, you just do y over x. So for example, for an angle of 30 degrees, the cosine of 30 degrees is root 3 over 2, and then the sine of 30 degrees is 1/2. And you can also try looking for patterns on the unit circle to try like memorizing them. So one that I usually notice is that the denominators going like away in this direction are all like 3, 4, 6. So 3, 4, 6 here, 3, 4, 6, and then going from the bottom as well. And another one that I remember is that since when you have like a 30-degree angle, I guess, and then there's like the long horizontal side and then a shorter vertical side. That's how I remembered that the root 3 over 2 is the x-coordinate. But if it's the opposite way, if the horizontal side is shorter than the vertical side, then I remember that it's 1 over 2. I don't know, just make sure it works for you. Okay, and I think Derek and Minnie covered this briefly last week, but there's something called coterminal angles. So in this drawing here, the original angle is in green, and the initial side is the right portion of the x-axis right here, and then the terminal side is the part that the angle goes up to. So the positive coterminal angle is outlined in blue, so it goes in this direction, the same direction as the original angle, but the negative coterminal angle is in red, and it goes in the opposite direction of the original angle. So a coterminal angle is essentially an angle that has the same like measurement or like meaning as another angle, and you can derive a coterminal angle by subtracting the initial one from 360 and making the number negative, or adding 360 to the initial number. So to get the negative coterminal angle, usually like I'll take this drawing into like as an example. So you just do 360 minus 45 and then make it negative. So the negative just tells us that we're going in the opposite direction. So we're going clockwise instead of counterclockwise, because we usually go counterclockwise when we're just doing angles in general. Or we can add 360 to the original number. And when we add 360, we're just adding an extra like circle around it, I guess. So just 45 plus 360 got us to 405. And it goes in the counterclockwise direction, same as the original angle. Okay, so just as a warm-up, I think you guys can put it in the chat. Um, So let's start with part A. Use the unit circle to the left to find the value of the given trigonometric functions for each of the following angles. So this time I'm giving you the unit circle. In other problems, they might not. They probably won't actually. So first let's start with 7 over 4 pi, and find the sine of the angle, the cosecant of the angle, and the tangent of the angle. And remember, cosecant is just 1 over sine.
Also, we've like provided a worksheet that we kind of want you to do. It's like you don't have to like um exactly get it right. It's basically helps you check your answer because it has like a little validation thing. So if you put in your answer and it's not right, you can try again until you get it right. And like if we don't go over it, you can be like, "Hey, I didn't get this one right. Can you please help me with this?" or something like that.
And you guys can like say done in the chat if you want to, just to let us know when you want us to move on. And while you're at it, you can also do part B, so negative 240 degrees.
And also just make sure that this is like general, like if you put it in a wrong way or it's like it doesn't recognize it, then it'll probably say it's wrong. It's just there to like help you out.
Yeah, I think it's like case sensitive or something. And for part B, remember that COT is cotangent, so 1 over tangent, and then secant is 1 over cosine. Okay, we'll give you guys like 1 more minute and then I'll review how to do it. Okay, so let's take a look at these. So 7 over 4 pi, it's right here, just 315 degrees. So I'm just looking at like where it's at on this like quarter of the unit circle. We know that the coordinates have to be root 2 over 2 and root 2 over 2, like either positive or negative, because it's halfway between 270 and 360. So since it's in the fourth quadrant, we know that the x-coordinate has to be positive and the y-coordinate has to be negative. So the sign corresponds with the y-coordinate, and so we know that the sine of 7 over 4 pi is negative root 2 over 2. And the cosecant is just 1 over sine, so we can just flip that upside down, so that turns into negative 2 over square root of 2, and then if we rationalize it, we get that, I believe it's negative root 2. And then for the tangent of that angle, we just divide the sine by the cosine, so we do negative root 2 over 2 divided by root 2 over 2, which is just negative 1. And then for negative 240, it's negative, so that tells us that we're measuring the angle in the clockwise direction. So we're going from this point and then we're going this way. So we're going up to 120. So negative 240 is the same thing as 120. And I guess let's start with the cosine because it's easiest. Since as we talked about, it's like 30 degrees from the like nearest, I guess like axis, and the horizontal distance is smaller than the vertical distance, we know that the x-coordinate has to be either positive or negative 1/2, and then the vertical coordinate has to be positive or negative root 3 over 2. So since it's in the second quadrant, we know that the x-coordinate is negative and the y-coordinate is positive. So now we can find out that our cosine is negative 1 over 2. And then let's do our secant next. So our secant is 1 over the cosine. So we said that the cosine was negative 1/2. So if we just find the reciprocal of that, that's just negative 2. And then lastly, our cotangent of that angle, we have to divide the sine by the cosine to get, sorry, we have to divide cosine by sine to get the cotangent, because to get tangent, we divide sine over cosine. So doing negative 1/2 divided by root 3 over 2 gets us negative root 3 over 3. So those are our answers for all of those. Just let me know if you have any questions. Okay, so now we can like go on to actual questions. We're past the unit circle warm up. So if sine of t is 3 over 7 and t is in the second quadrant, find the cosine of t. And I'll give you a hint. This kind of uses the Pythagorean identity of sine squared x plus cos squared x equals 1. And if you don't get it, don't worry. This is kind of hard to go into immediately. I'll show you how to do it, and then we'll do another one, another similar one right after it. And I guess I'll give you guys like 3 minutes to do it because it's a little bit tricky. Okay, let's take a look at the answer to this one. So let's start by like how to approach it. So they like show you how to put it on a unit circle because they give you that the sine of the angle T is 3/7. So they made the y-coordinate 3/7, and we're looking for the x-coordinate now. So as I said before, like you start with the Pythagorean identity, cos squared t plus sine squared t equals 1. So since we know that the sine of t is 3/7, sine squared t is equal to 9/49, so we can just plug that in. And now we get that cos squared t equals 40/49. Just subtract this from both sides. And taking the square root of that, you get plus or minus 2 root 10/7. And we know that the angle is in the second quadrant, so the x value or the cosine value has to be the negative version of that angle. Okay, so question 2, if the okay, sorry, I was just making sure that it said that t was in the second quadrant. Okay, if the cosine of t is 24/25 and t is in the fourth quadrant, find the sine of angle t. And do it just like we did the last question. It should be easy now, so I'm gonna give you guys 2 minutes on this one.
And don't just write your answer in the Google form, do write it in chat so like we know if you guys need help because we can't see what you're writing in the Google form.
Okay, so let's take a look at this one. So it says in the problem that it's in the fourth quadrant already, so we know that the cosine or x-coordinate is going to be positive and the sine or y-coordinate is going to be negative. So again, we start with the Pythagorean identity of sine squared x plus cos squared x equals 1. And then again, we just plug in the value that they gave us for cosine of x, which is 24/25, and then square that, subtract that from both sides. Sine squared x equals 49/625. Take the square root of both sides, and then we get that sine of x is plus or minus 7/25, but we already identified that the sign had to be negative, so we know that the sine of x is negative 7/25. Any questions? Okay, so this one's pretty simple. Evaluate sine the sine of pi over 3. I'm going to give you guys just 1 minute on this one because it's a simple unit circle question.
Hi Audrey. We're just doing some trigonometry real quick. Um, since you haven't been here, I think, from the start, just hang tight and Shreya will explain it.
Okay, so let's go over this one. Again, it's pretty simple. Pi over 3 converts to 60 degrees if you just multiply by 180 over pi, because again, going from radians to angles, but you don't really need it, but if you do, it's 60 degrees. Just looking at the unit circle, again, the pattern is like pi over 3, pi over 4, pi over 6, going this way. So we know that since it's 30 degrees from the 90-degree like axis, I guess, we know that pi over 3 is shorter on the horizontal side but longer on the vertical side. So we know that the x-coordinate has to be less than the y, therefore it has to be 1 over 2 on the x-axis and then root 3 over 2 on the y-axis. Okay, again, another simple one. Find the coordinates of the point on the unit circle at an angle of 7 pi over 6. Okay, so I've just added another diagram of a unit circle here. So it was asking for 7 pi over 6, which is right here, same as 210 degrees, and the coordinates are negative 3 root 3 over 2 and negative 1 over 2. It's in the third quadrant, so we know that it has to be like negative negative, and it's also like longer on the horizontal side and shorter on the vertical side. And I added some things here, so if you can't remember what quadrant the angle's in, try converting it to angle form. If it's between 0 and 90, then it's quadrant 1 and so on. In this case, 7 pi over 6 is 210 degrees, which is between 180 and 70. So quadrant 3, and then since 210 is 30 degrees past 180, we know that the x-coordinate is bigger than the y-coordinate. Okay, so this one gives you a point and it's asking you to find the secant of t, the cosecant of t, and the cotangent of t. And t is referring to the angle, like the initial angle. I'll give you guys like 3 minutes on this one since it's asking for 3 trig functions. Okay, so it already gave us the point in the question, so it gives us the coordinates. So now we just have to kind of like just use the trig functions now. It's essentially what we did in the warm-up. So remember the secant is 1 over cosine, so 1 over the x-coordinate, and it shows you how to set that up, and then they rationalized it, and then you get negative 2 root 3 over 3. Cosecant is 1 over sine, so 1 over the y-coordinate, which is 1 over 1/2, which is 2, and then the cotangent is 1 over tangent, and remember tangent is sine over cosine, so cotangent is cosine over sine, so x over y, and then you divide root 3 over 2 by 1/2, and that leads you to negative square root of 3. Okay, last one for the unit circle. If the secant of angle t is 2, what is the secant of negative t? Okay, so the answer for this question is 2. So it's asking for the secant of the negative version of the angle. So secant is 1 over cosine. So in this case, that would be 60 degrees, because 1 over the cosine of 1/2, like 1 over 1/2 is 2, so we know that it's referring to 60 degrees. So going in the negative direction, because it's asking for the secant of negative t, so we're going in the clockwise direction. That gives us 300 degrees, and it has the same x-coordinate, which means that it'll have the same value for secant, because if it has the same value for cosine, just the reciprocal of that will also be the same. And you don't have to identify like an angle necessarily, since you know that the secant is 2. So let's say it was if the angle was in the second quadrant. So you're traveling from here to like here, for example. Then to find the secant of the negative version of that angle, we just go in the opposite direction, which means that we end up in the third quadrant. But in both the second and the third quadrant, the x-coordinate is negative. So we know that the reciprocals of those x-coordinates are also going to be negative, so they're going to be the same. I hope that makes sense. Just let me know if I should go over that again. Okay, now we're going to do Pythagorean identities. So just a quick review of the trig functions. I think you guys should know these by now, but cosecant, secant, and cotangent. And then the Pythagorean identities. So last week we went over how to like derive these. So how to get these bottom two equations out of this top equation. And remember, we know that this is true because of just a unit circle. So since the x-coordinate is cosine and the y-coordinate is sine, it's just using the Pythagorean theorem. Since we also know the hypotenuse is 1 because unit circle has a radius of 1, so just sine squared of that angle plus cosine squared of that angle equals 1. And then these two, they're just different versions of this top identity right here. Okay, so question 1, true or false? Tangent of theta times cosine of theta equals sine theta. This one's pretty easy. I'll give you guys a minute to do this one. Okay, so the solution just shows you how to do it, but essentially they're multiplying. Um, Actually, this solution's a little bit confusing, but we know that tangent is sine over cosine. So if we just replace this tangent theta right here with sine theta over cosine theta, and then multiply by cosine theta, the cosine thetas cancel because the denominator and then here. And that just leaves you with sine theta equals sine theta. So we know that it has to be true. Okay, so question number 2. So it gives you this right here, and it's asking for which identity this simplifies down to. And I'll give you guys like 3 minutes on this one because it's a little harder. Okay, so um, sine has like a property that the sine of negative x equals negative sine x. So that's essentially how they got from this step to this step. So since sine of negative x is negative sine x, they just wrote that out. And this is just the difference of squares, so they simplified it to 1 minus sine squared x. And using that original Pythagorean identity that cos squared x plus sine squared x equals 1, they just changed that into cos squared x. And yeah. Okay, question 3. Is this true or false? The secant squared of theta minus 1 over the secant squared of theta is equal to sine squared theta. Okay, so this one's a little bit longer. So let's start with the left side to try and make it equal to the right side. So secant squared theta can be made into tan squared theta plus 1 because of the identity right here. Secant squared theta is equal to tan squared theta plus 1. That's where they got that from. And the 1's cancel here because 1 minus 1. So you're left with tan squared theta over secant squared theta. And that's essentially the same thing as multiplying tan squared theta by 1 over secant squared theta. So 1 over secant squared is just cosine squared. So, and then they're converting tangent into sine over cosine. And now the cosine and cosine cancel out in the denominators, and that equals sine squared theta. So now we know that both sides are equal. And they also gave you like the work that the identities that they used on the side here. Okay, next one. The cosecant squared of x multiplied by 1 plus the sine squared of x is equal to the cotangent squared of x. Is this true or false? Okay, so this one is false. I guess there is no solution to this one. Hmm. Okay, and then this one says 3 sine squared theta plus 4 cosine squared theta equals 3 plus cosine squared theta. Is this true or false? Okay, and this one is true. So I opened up like a whiteboard, like an online whiteboard, so I can show you how to get there. So this is the original problem. And what I did was, since there was a cosine squared term on each side, I just subtracted this one from both sides, and that led me to 3 sine squared theta plus 3 cosine squared theta equals 3. And then I was able to divide both sides by 3, and that leaves you with our original identity, which we know is true. And let's go, okay, let's go back to this one. I'll show you why this one is false. So the problem is cosecant. 1 second, let me just copy this down. Okay, so cosecant is just 1 over sine. So I can change this to 1 over sine squared x times 1 plus sine squared x. I'm just going to work on the left side for now, so I'm not going to write down the right side each time. Okay, and I'm just going to multiply that out, so that gets us 1 over sine squared x plus 1, because that cancels out, and then that equals cotangent squared x, and that leads us back to, so we have 1 over sine squared x again, so that gives us cosecant squared x again, and then plus 1 equals.
You're sharing the wrong tab. Shriya.
What did you say, Annie?
I think you're sharing the wrong tab.
Oh no. I'm sorry. This is what I was trying to show. I'll give you guys a second to look at it and try understanding. So essentially I changed cosecant squared into 1 over sine squared because it's just how you do it. And then I distributed this out to both of these terms, and that simplified into 1 over sine squared x plus 1. The signs canceled out, and then equals cotangent squared x. And the 1 over sine squared x became cosecant squared x again plus 1 equals cotangent squared x. And let me share the original, the identity. So the original identity is 1, like the one that we know is correct, is 1 plus cotangent squared of theta equals cosecant squared theta, and that does not match this. So we know that it is false. Okay, so I think that's all for today. Thank you for attending class today, guys. Oh, also, if you have any questions, feel free to put it in the chat. Anything that you want to do next class, like Kahoots, quizzes, any topics that you want to cover, feel free to put it in the chat.
And also, since tomorrow is Labor Day, we're probably not going to have class, but we will update you if anything happens. We're probably going to move it to Wednesday, but we'll see. But you guys can always email us if there's like you guys want to make it to class and like you want a certain date. Yeah, thanks for coming, guys. You guys are always really patient, so we're grateful for that.
I hope Trig is a little bit